Welcome in mechanical system design. Today we will discuss about the topic the standard normal distribution curve and its applications. So the distribution curves or the standard normal distribution curves has a various applications. So it can be used to model the distribution of variable of interest. Then standard normal distribution curve allows us to make useful probability statement. Then human status and human intelligence can be predicted by using the HD curve. Then it is a probability distribution powerful tool for summarizing, describing the set of data. Then conclusion about the population based on the sample. Then a relation between the values of the random variable and probability of their occurrence. Then expressed as a graph or formulae. So these are the some applications or introductory part of the standard normal distribution curve. Now we will see the Abraham is the scientist who firstly discovered the normal distribution in 1733, who was the French scientist. Then second one is a utility. Notice this in the height of the army people. So he is basically from the Belgium, who again does the tremendous work in the distribution curve. Then next one is a Gaussian distribution after Carl Friedrich Gaussian was developed. That was the German scientist. Then Laplace proved the central limit theorem in 1810, who was the French scientist. So for the large size sample size, the sampling distribution of the mean follow the normal distribution according to the Laplace scientist. Then next is if sample studies is large enough, normal distribution can be assumed for all practical purposes. So this was the prediction given by the Laplace scientist. So this is the curve which is called as a normal distribution curve. So in that you can see the on x-axis and on y-axis there are certain parameters are there, and the distribution curve can be represented in the form of the histogram bars, and normal curve is the drawn with respect to the histogram bars. So if there is a random variable x, then such a distribution curve is called as a normal distribution curve. So the normal distribution curve as the mathematical function, so f of x is equal to 1 upon sigma into root of 2 pi into e raised to minus 1 upon 2 into bracket x minus mu upon sigma square. So this is a bell-shaped curve with a different center and spread depending on the mean value and standard deviation value, that is a sigma. So the constraints are pi values is taken as a 3.14159 and e value is taken as a 2.71828. So these are the constraints for this normal distribution curve equation. Then in case of normal distribution curve, it is the graph of a variable with respect to the frequency. So on x-axis there will be the random variable x, and on y-axis there will be the frequency distribution f of x. So here mu is the mean and sigma is the standard deviation. So by changing the mu, shift the distribution left or right. So changing the standard deviation sigma increases or decreases the spread. So the curve, normal curve is not a single curve but a family of curves, each of which is determined by its mean and standard deviation. This is again another different curve. So you can observe on x-axis there will be the random variable, and on y-axis there will be the frequency distribution. So here mu will be the 0 for first three cases, and for last case mu is -2. So for every mu, there will be a standard deviation. For first case, it is a for first curve it is a 0.2. Then for second, it will be the red curve is a 1.0. Then for yellow, it will be the 5, and for last one is the green curve, which represent the standard deviation sigma square is a 0.5. So in this way, we can represent the different curves for the different mu values and for different standard deviation. So these curves are called as a normal distribution curves. Now, what is meant by mean, or how the mean is mu is calculated, that we will see now. Now, mean is nothing but it measures the central tendency of the population or a sample or the variable. So the center or middle of data set around which observations are lying, that will be called as a mean. Assuming that frequency in each class is uniformly distributed and represented by midpoint. Therefore, the mean of grouped data is given by x bar is equal to, our mean is represented by x bar, where n is the number of observations. So 1 upon n into the sum of fi into sum of xi, where fi is the frequency of each class interval and xi is the midpoint. So the mean is represented by x bar. So it will be the sum of number of observations divided by total number of observations. So that will be the formula for mean. Next is the standard deviation. That will be the standard deviation. It measures the dispersion of spread. The average deviation of observation around the mean. Next, standard deviation, it is the compactness or variation of the data. So the definition of the standard deviation is the root mean square of deviation. So it is denoted by the sigma. So SD is equal to square root of variance. So square root of 1 upon n sum of xi minus xi minus x bar bracket square. So where n is the number of observation, x bar is the mean of the frequency distribution, and xi is the midpoint of each class interval. So in this way we can calculate the standard deviation sigma. Next, properties of normal curve. So there are some important properties of normal curve. So the normal curve is perfectly symmetrical about its mean, that is a mu. Then it has a so-called a bell-shaped form, or it is also called as a bell-shaped curve. Then it is a unimodal and skewed curve. The mean of distribution is the midpoint of the curve, and mean is equal to median is equal to mode in case of normal distribution curve. It is a 2-point inflation curve. So the tail are asymptotic. Next, as no observations, n tends towards infinity and the width of the class interval tends to 0. Therefore, the frequency polygon approaches a smooth curve. Then the area under the curve is measured in the standard deviation from the mean. The total area under the curve and x-axis is equal to the 1 square unit based on the probability. Then transform to a standard curve for comparison. The properties of area under the curve is the relative frequency of the z score. Therefore, mean is equal to 0 and standard deviation is always equal to the 1 for unit normal distribution curve. Then next one is a general relationship. If it is standard deviation is a plus minus 1, then the properties are about the percentage of area under the curve is 68.26 for plus minus 1 standard deviation. For plus minus 2 standard deviation, the area under the curve will cover the 95.44%. And if we go with the plus minus 3 times standard deviation, then about 99.72% area under the curve is covered in the normal curve. Then 65, 95, 99.7 rule. Consider a distribution of a group of runners. Mean is a 127.8. Standard deviation is 15.5. Therefore, 68% of the data is denoted by the red portion. 95% data is denoted by the green zone, and 99.7% data is given by the blue zone. So that 68% data will be your plus minus 1 standard deviation. Then green zone will be plus minus 2 standard deviation, and blue zone is a plus minus 3% of standard deviation. So 68% of 120, that will be nearly equal to the 82 runners. In fact, 79 runners fall within 1 plus minus standard deviation, that is the 15.5 kg of the mean. So in this graph also you can see the 112 to 143 is the highest range, and 127 is the central or mean value for that property or percentage. Next one is the standard normal distribution curve denoted by the Z. So the standard scores are expressed in standard deviation unit to compare the variable measured on the different scales. There are many kind of standard scores. The most common is the Z score. So how much the original score lies between or below the mean of the normal curve. All the normal distributions can be converted into the standard normal curve by subtracting the mean and dividing by the standard deviation. So the Z score, so what is the Z score? As a Z score is a raw score expressed in standard deviation unit. So here is the formula for a Z score or calculation of the Z, which is equal to the x minus x bar divided by ES. So comparing the x and Z units, so if in x is the random variable and Z is the standard variable, so what we need is a standardized normal curve which can be used for a normally distributed variable such as a curve is called as a standard normal distribution curve. Then application of the normal curve model are using Z score to compare two raw score from a different distribution. Then it can determine the relative frequency and probability. Then it can predict or it can determine the percentile rank. Then it can determine the population of scores between the mean and particular score. Then it can determine the number of people within a particular range of score by multiplying the portion by n. Then using Z score to compare two raw scores from the different distribution. So you score 80 out of 100 on a statistical test or statistic test, and your friend also score 80 out of 100 on their test in another section. Here, congratulations, you friends say we are both doing equally well in statistics. What do you need to know if the two scores are equivalent? The mean. What if the mean of both tests was 75? You also need to know the standard deviation. So what do you say about the two test score if the yes in your class was 5 and yes in your friend's class is a 10? Therefore, what is the score for your test? Raw score is 80, mean is 75 and S is 5. Therefore, Z is equal to x minus x bar upon S. Therefore, Z is equal to 80 minus 75 by 5. So, Z is equal to 1 in first case. For second case, what is the Z score for your friend's test? Raw score is 80, mean is 75 and S is the 10. Therefore, Z is equal to x minus x bar upon S. Therefore, Z is equal to 80 minus 75 upon 10, which is equal to 0.5. What do you think did better on their test? Why do you think this? So this is the standard distribution curve. So it is used for the considering the area under the normal distribution curve. So this is the tabular form for which we can get the different areas for the different Z values. So the area under the curve, how the area under the curve is calculated. So the procedure to find the area, first compute Z score, then substitute a score of interest x bar for xi, then use sample mean for mu and sample standard deviation for s. The formula changes a raw score xi to the standardized score z. Therefore, z is equal to x minus x bar upon s. So finding probabilities, how the probabilities are find out. The areas under the curve can also be expressed as a probability. If a distribution has x bar is equal to 13 and s is equal to 4, what is the probability of randomly selected a score of 19 or more? Find the z score for xi is equal to 19 and z is equal to 1.50. Find the area in Z table, which is equal to 0.9332. So the probability is 1 minus 0.9332. So that will be 0.0668 or 0.07.